Okay, let's get started. Today's topic, Advanced 3D Modeling and Rendering, second class, plus a series of sequence of image rendering, so-called animation making. Okay, that's the topic for today's lecture. So briefly, we are in the 12th week, and we're going to have midterm exam today. Okay, firstly, we're going to have lecture and 2 more hours for the lab exercises, and we're going to have the exam 5 p.m. okay, today. So rest of the week, we need to develop your final project individually for the individual final project, and like last week, I like to see you one by one for developing final project. Some partially, we're going to use lab exercise hours for your final project development. Okay, lecture, some theoretical background and of CAD and graphics. So I think you need to keep open your eyes for today's lecture, because today's lecture covers some review part what we have walked through this semester, okay, in terms of theory and behind the technologies. That's going to be the final prep for the exam, okay. Also, today's lab exercise is one of the subjects for the exam, okay. So no need to worry about exam. You don't need to see the old material. Just keep focusing on today's material, okay. That's my point in this page. We are going to have some series of lab exercises. Firstly, V-Ray renderer in 3D Max, as well as some mental ray based things, mostly using texture map, okay? How to handle texture, that's the topic. And then move on to some series of lab exercise, but this one is related to the lab exercise number 0 actually, cutout map in mental ray, okay? So anyway, 1 hour lecture, 2 hour lab exercise, and 1 hour exam. So let's get started, okay? Let's quickly review what we have walked through, even from the course last year, Intro to Digital Design, okay? We need to review why we are handling some design computing issues rather than some SketchUp, V-Ray, 3D Max specific issues, okay? So firstly, I like to bring your attention again some concept in high level, low level. Similarly, some higher level of detail versus lower level of detail. As you know, something introductory, outlined, general theory, they are, or some coarse detail, and so-called high level, okay? So we are dealing with high-level design computing in this way: enhancing digital communication skills, developing the capability of design computing, practicing digital design presentation. They are some high-level definitions, high-level phrases. But in lower level, in detail level, particular level, some specific theory, you need to train by yourself some techniques on AutoCAD, 3D Max, mental ray renderer, and so on, okay? Training precision drawing tools such as AutoCAD, SketchUp, Rhino, and so on. So that's the difference between high level versus lower level. We have learned some geometric modeling in terms of 3D surface-based model. So surface-based model has polygons, okay? Many polygons for detailed level of detail. Fewer surface polygons probably is looking like this, okay? Low level of detail. By using human face structure, you can find out what is higher level of detail, okay? Higher LOD and lower LOD. Let's get started reviewing 3D modeling and design representation issues. You know, this one single slide diagram explains almost everything in terms of CAD history, okay? I told you 3D Max, Rhino, SketchUp, they are dealing with this part, okay? Surface-based 3D model. But actually, we are working for the drawings too, okay? Precision drawings by AutoCAD plans. Still, 2D images, 2D drawings are critical, especially in industry, okay? So this is surface-based 3D model definition. Surface-based 3D is very good to visualize, okay? Very good to visualize any type of 3D objects, not only in real-world objects, such as interior architecture elements, furniture, buildings, also in the cyberspace, such as games, okay? So mostly game engines or game representation, game engines are surface-based 3D model. But the problem is we are dealing with a real-world object. You're not going to deal with some game characters, game environment. We aim to develop physical, real-world environments in interior architecture and design, okay? So what should we model, actually? So that is why we need to keep going on to the next phase, advanced features in computer graphics and CAD, so-called solid model, parametric model, building information model. So this page simply shows you the definition of solid model, unambiguous computer representation of a physical object, okay? This one is, of course, 3D, but they are all planes, zero thickness planes. In real world, there is no such object, okay? This tangled surface also problem, okay, in terms of solid 3D model. This line, no weights, no radius, zero thickness, zero radius, this type of value, object, line, couldn't be existing in real world. 3D version of maybe a string, Klein's bottle, also not valid, okay? You know, devil's spoke, that is an illusion. It's invalid. And this type of 3D representation, line stroke, wireframe view representation is not only this one, but also a bunch of more possible representation. So it is ambiguous, something vague, okay, in terms of its geometric definition. That is why we need solid model. So now you can differentiate solid model from surface model in terms of its definition method. For better understanding, we reviewed some geometry and topology issues, okay? How to represent a shape, this rectangle shape, by computers. For computers, they are collection of points at first, okay? 2.1, 3.2, 2.3, 1.2. 4 different location, X, Y coordinate system represents 4 points, and their connection made 4 lines. One single enclosed polygons generates one single face, okay, one single surface. So at the end, computer can recognize this is a rectangle shape, and its color is, at this time, yellow. But that kind of definition is not enough. We need to make some relationship, okay? So V0, V3, and the connection made edge number 0. At the end, the face can be composed of those elements, okay, edges. Vertices, edges, faces, okay? So topology defines relations, okay? So relations, take a look this relation. V0 through 1, 2, 3, and again V0. And take a look this one. V0, 1, 2, 3, and V0. The same relation, same topology, but they are looking totally different, simply because they are geometric Cartesian coordinate points, location is different, okay? So-called same topology, but different geometric shape. But at this time, same points, same geometric points, same location, but different shape. simply because their relations are different, okay? So both geometry and topology are necessary for valid definition by computers. In terms of mathematics, we need to define both geometry and topology without any problem. Geometry defines values of points. Topology defines relations between points. So here are the terms. Geometry terms, space, surface, line, point, and topology terms, shell, face, edge, vertex. So you can find out those terminologies in your 3D Max interface, Rhino interface, or your own scripting to create your own shapes, okay, in 3D world, 3D computers. Let's take a look at problems of an unclosed surface. If you extrude this rectangle shape, no problem. But we experienced when we import CAD file and simply extrude some hollow walls generated simply because the points, vertices, were problematic. That's why we applied some weld to remove unnecessary or some wrong definition points, vertices, in order to create this kind of correctly defined surface-based 3D object. Also this one, some problems, okay? So in terms of topology, computer can recognize whether this one is enclosed loop or not, okay? In order to create valid 3D model, even if it's solid or surface, it doesn't matter at this time. Closed surface, closed loop can make some valid 3D shape. That's the point, okay? So let's take a look at what we have learned, geometric modeling. But again, geometric modeling against information modeling, okay? Information modeling for building is so-called BIM, building information model, building information modeling. Actually, geometric modeling is one part of information model. Simply say, information model has geometric model as one type of its information. This one is subset of this one, okay? So this type of 3D representation, 3D surface model, that's what we created in lab exercise hours using 3D Max and other applications such as SketchUp and so on. But anyway, old-fashioned 2D drafting and some computer-based 3D representations using 3D applications. What's next? You remember homestyler.com, the tablet version, PC version, and smartphone app versions, okay? So this kind of home styler is very easy to use. You can simply drag and drop and simply adjust numbers, values. And this one is in 3D actually. But take a look. Computers understand walls, doors, and its dimension. In terms of computers' perspective, they are not just the simple editable poly or rectangle shape or just collection of lines, edges, okay? In other words, this is building information modeling related tool, okay? Not just the simple AutoCAD-like tool, okay? That's the point. That is why you can make this kind of home styler model into Revit. You can export Revit file. Revit is building information modeling tool, okay? So PC version Revit can import this kind of home styler file, okay? This is the app version of home styler. Have you used this one, smartphone version of home styler before? Did I demonstrate you? Let me show you this one, okay? Just a quick demonstration, just for your information, okay? Okay, let me retake. Okay, I just took the picture. If I click next, take a look what happened, okay? searching for visible corners, which means based upon this digital image just captured, this application detects the corners and the walls. Okay, so let's take a look at the corner definition like this. Okay, this one, now you can redefine the geometry. Okay, actually, if I made this wall and this wall around here, okay, let's take a look at this kind of auto detection. Okay, this is the corner line. That means take a look at this surface. Now 1, 2, 3, 4, 5 surfaces auto generated based upon this image you just create. Okay, and if I go to next, and you can simply adjust the height of this. Okay, just as an example test, let me assign 2.4 meter. Okay, for the height. So now this picture is kind of recognized by this homestyler.com application as an environment, given environment. So what you can do now is simply load some interior facilities, such as, how about this one? Sitting sofas. So what if I load this one? Okay. Or, okay, how about this? Add to design. So now this sofa is just loaded here, and you can rotate and place. Because of some scale, some scale problem, this one is, okay. You can rotate and place. Actually, I just made some mistake in terms of its dimension. That's why this one is looking so small. But anyway, if I adjust and put some correct height numbers and some modification, you can navigate some objects such as tables, coffee tables, like this, add to design. And now this one has coffee table and the couch. You can make some adjust model. And if you select these walls and detect some yellow colors, the surface of this wall, you can adjust, modify, change the material to fabric or even stones, bricks, or different paint colors, whatever. Okay, so actually the picture for this one is not that good example. But what if you take some empty room and auto detect of the corners, and now you can load that onto your blank environment for decoration, interior design, some material changes, loading this kind of library. Okay, computer recognizes the living room, couch, and the table, and amount of more library in terms of some housing facilities. Okay, so if you click this one, you can repaint, or you can adjust some environment, and so on. Okay, so this is just one example of given app, which facilitates the power of building information modeling. Okay, this one also has geometry, but this one has building component, furniture element, not just editable polis geometric shape of that sofa or some other type of objects. Okay. Okay, let me go back to the course material. Object-based design, object-based decoration, and camera-based edit, some advanced techniques you can apply for developing your design. Okay, that's the point. That's the big difference from geometric modeler such as SketchUp, 3D Max, and so on. If you save the model in AutoCAD file from HomeStyler, take a look. Even if you select this door object, computer, AutoCAD recognizes this one as layer, color, position X, position Y, position Z. That's it, okay? But in BIM application, Building Information Modeler, computer recognizes this one is double panel 1 and its dimension. What you need to do is you can change frame material, finish material, and its dimension, sill height, frame height, thickness, and so on. Okay? Based upon this kind of edit in parametric way, you can modify. That's the building information model-based approach. Okay? When you are designing, if you have your own design idea, you need to make an abstract, okay? Abstraction. Typically, elevation, section, floor plans, axonometric, isometric views, this kind of standardized, okay, typical representations are so far the most representative design representation. But nowadays, we are using computers, 3D, but geometric models, okay? But advanced one is we have those geometry as well as amount of more information. That's the point of information modeling, okay? Take a look. In Revit, this is a door object, door-related properties. Computer knows this is a door. Drawing visualizations are one of the use of this model, okay? From this model, you can capture rendering, views, styles, and so on, okay? BIM authoring tools can draw this door, model this door, okay? You don't need to draw the points and their connections and edges, polygons, or extrude and put some segment to divide this kind of pattern. You don't need to do that, okay? Simply assign and modify the door object. That's the difference. Take a look this one. When you focus on geometric shapes, we use computers for doing what we have drawn, okay? You need to draw floor plan, axonometric, but if you have computers, you draw axonometric or 3D floor plans by AutoCAD, okay? But think some smart way. What's the smart use of computers? Focusing on information, okay? Focusing on almost everything for designing and construction. Let computers do what we have done, okay? In terms of building life cycle. That's the point and the focus of this approach. Let's take a look. These two different images. But actually, in terms of visualization, they are same. But this one, point 1, point 2, rectangle 1, rectangle 2. This one has point 1, 2, 3, 4, wall 1 and 1 through 4, and space 1. Okay? This is building information model, and this is geometric model. Okay? Very different. Even if they are looking totally same, in terms of their definition, they are totally different. What is for design, building design, interior architecture design? Of course, this is advanced approach, even if they are looking same. Geometric modeling, building information modeling, okay? You know this one, okay? When you create a box shape, you can turn this object into editable poly to control vertex, edge, face, shell, to modify its geometric shape. What's next? In terms of advanced geometric modeling, we have a lot of geometric modifiers in 3D Max modifiers, Rhino, Grasshopper, and so on, okay? Easily edit its geometry, not only based upon this kind of editable poly, but also amount of advanced modifiers exist. But actually this way, parametric modeling, building information modeling, it's a smart way, okay? Define part and apply this part to design. Some separate part-based modeling, parametric modeling, building information modeling. In next semester, in digital design class, we're going to deal with this part, okay, using Revit and some other applications, something advanced way. But anyway, now we have learned this part and some part of this way, okay, focusing on geometric modeling in 3D. How to represent your design, how to build your design. In terms of theory, Vitruvian Man, drawn by Leonardo da Vinci. Vitruvian Man is sort of ancient, kind of the first architect, kind of ancestor architect. I don't know how to say. Anyway, 2,000 years ago, Marcus Vitruvius Polio suggested those drawings. What kind of drawings? Plans, elevations, perspectives, to convey design intent, okay? In other words, your plans, your elevations, that kind of typical representation has been lasting 2,000 years. We can say it's a long time, but in the perspective of human history, it's not that long, okay? In Renaissance period, Leon Battista Alberti also wrote some similar books. He distinguished architectural design from construction, okay? That means only for 500 years, we have separated design and construction. Rest of history, design, construction, they always integrated, okay? 100 years ago, modern architect Louis Sullivan coined the famous phrase, form follows function. This one simply explains about modernism, okay? Box-shaped, efficient, simple buildings, okay? Anyway, also referring to Vitruvius. So based upon this very briefly described history, now we have computers. 40, 50 years, okay? Just 40 years. At the beginning of computers, we used 2D drawings, simply because 2,000 years ago, we invented drawings, standardized drawings, and computers also draw something. But of course, the most cutting edge, advanced feature is building information modeling. Something advanced, something different from conventional approaches, okay? That's the point. The first approach we have learned is geometry-oriented approach, okay? I showed you this one several times. And this one means editable poly, okay? Control edges for changing your shape in SketchUp, in 3D Max. Controlling polygons for making anything in 3D Max, okay? But take a look, this one. One site has one or many buildings. One building has one or many floors. One floor has one or many spaces. Space can be grouped by several different names. Our department area, building common area, rest area, office area, and so on. Interior facilities can be contained by a single space. So you are focusing on interior facilities or furniture or interior finishes for specific space in small room interior decoration or interior design course, okay? So this is architectural approach to design a building interior or buildings. Also a lot of building components, building hardware, physical elements such as roof, beam, column, walls, windows, doors, and so on, okay? So this kind of structure, this kind of well-organized definition about the building is simply say building information model, okay? Again, this type of standardized representation. It's also important and critical for industry perspective, but we have even advanced features, building information modeling and so on. In terms of design mode, in mode of thought, mode of expression, mode of production, what is the medium's unique quality? What is 3D Max unique quality? 3D Max has Autodesk material, really powerful, predefined presets. 3D Max has mental ray renderer, fast and decent visualization. Also, it has a bunch of geometric modifiers. What is the SketchUp's unique quality? Easy to use, lightweight, fast, okay? What is the Rhino's unique quality? It has Grasshopper, very geometrically and parametrically well-defined tool for creating geometry, okay? So we need to maximize the meaning of your design, focusing on design itself, not computer techniques. That's why we need to move on, okay? Why CAD and graphics? Again, this is the question that I show you at the beginning of this semester in CAD and graphics 2 class, okay? Especially why 3D graphics? Simply for enhancing your design visualization skills. Design should be visualized, okay? And then that design can be realized. For moving forward to advanced design computing issues such as BIM, I already showed you this kind of answers. Computational model at this time, 3D Max model, SketchUp model, AutoCAD model, but this one's supposed to be even smart model, okay? That's the next phase issue. One source, multi-use. From this computational model, you can get any type of digital design presentation method, tools, okay? So this computational model, so far, it was geometric model, 3D geometric model. But what if you add more information about the building? That is building information modeling, okay? You have submitted those finals, even in freshman stage, okay? This kind of visualization using geometric model, very easy, okay? Not that hard. No complicated things you need to take care of. Simply use V-Ray or SketchUp style, rendering, reflection, some lights, controlling lights, some different type style of visualization in order to create this kind of easy to make realistic visualizations. So that's why I put emphasis on some behind the technologies such as computing, engineering, computer science theories, what you need to know, even Windows systems, and some fundamental theories about design computing, as well as our main lab exercise focus, specific applications, such as 3D Max, mental ray, V-Ray, okay? So even more things about design computing, there are a lot of more things, such as digital fabrication, 3D printing, drones, and so on. That's why I showed you some cases, examples, okay? 3D visualization of design. At first, of course, what is your final presentation subject? Still image? That's one of your options, okay? One single image to represent, to visualize your design in maximum quality, okay? So we have used pencils, designed by hand, but designed by computing. That's what we are working on in the classroom. So the media changed, okay? Media changed from this kind of pencils, pens, rotating pens, nowadays computer software and hardware, okay? By using such computing hardware as well as some additional environmental technologies such as cloud computing, servers. For example, take a look this famous Church of Light. This one modeled by someone and uploaded into 3D warehouse. You can easily download and control some light options and simply visualize this scene, okay? Thanks to network, internet, cloud computing. Thanks to cloud computing, you can get your own mental ray render image from homestyler.com website, okay? You don't need to render. Just simply request snapshot, and then you can get the render file, okay? This kind of realistic visualization by SketchUp, V-Ray-based render case example, very photorealistic. And I showed you at the beginning of the semester, IKEA brochure designed by, modeled by, and rendered by computer applications for their own purposes, objectives, for different type of tools. So they used this kind of application for visualization. In terms of still image making, okay? That's the one way of generating image, still image for your design. So this is one of the topic for your final. Secondly, you have another option to present your final presentation, okay? Final project. 3D visualization of design. Second way is image sequence. What is image sequence? It's the same to still image, but a lot of images in its own order, okay? Simply say animation. You know this kind of flipbook animation, okay? The flipbook animation example here, let's take a look at this case quickly. Take a look. The prose and video-based design presentation, so-called multimedia-based presentation. Video is easy to follow. As a picture is worth 1,000 words, so even if a certain idea is clear orally, it can be clearly stated via pictures and diagrams. Sequence of images, okay? Seeing is believing. So whatever you describe in oral presentation, showing images, sometimes showing this kind of video, much effective. That's the point, okay? So I'm going to show you later some video-based design presentation cases by your senior students in our department. Lots of examples. But actually this semester, final, I'm not going to ask you to submit this kind of video-based presentation. But one option is still rendering image, your edited image, or sequence of images, okay? So-called animation. What is the animation? Take a look at this video presentation. Typically, it has introduction, title text, some brief overview, and it has concept description using background music and its own diagramming, okay? Or your own taking videos or pictures. And this one usually has ending credit, some more information. But the most important part is your design representation, your 3D model, still images, or working animation, whatever, okay? Take a look. All other parts can be created by video making tools. But take a look, this part, your 3D model. You have to use 3D surface-based modeler or any other type of applications we have walked through, okay? Such as 3D Max-based animation making you need, okay? For this part. So take a look. This one shows you why I'm saying sequence of images. This video file shows you some construction process, okay? There is slab. Words are created by this way, and at the end, the final scene, okay? The sequence of image render required for making this animation clip. This one just 4-second animation, Okay, it's just 4 seconds animation. For making this 4-second animation, you need to render 120 render images for several minutes. Okay, actually this one not that time consuming, quickly render by your computers, but complicate geometry. One single shot render takes sometimes 1 hour. For 1 second, 30 renders, 30 hours for 1 second. Okay, if your model really complicate. That's why we need to know some more applications. We're going to deal with those parts next week and next after next week in lab exercise hours. Okay, animation clip making. We need to know encoding, codec. Okay, simple applications to convert video formats, converting images, converting video files. We need to know how to capture your screen to transform that one into another type of video for recording your working environment, working process. And this is the Photoshop of animation. Okay, this one is Adobe After Effects, video version of Photoshop. Okay, you can easily control layers, background, and composition like Photoshop. Okay, but original file is video. You can edit video. Premiere, this one is kind of commercial and very professional application for editing videos. But some easy to use Flash or Power Director, Vega, there are lots of easy to use applications for video making. But actually this is not the subject for today or next week. But anyway, there are amount of available applications to create your own design presentation in video. Okay. But actually, even if you know a bunch of technologies, techniques, skills in design presentation, Photoshop, After Effects, Power Director, Premiere, but always the content is matter. Okay, your design content also very important thing, but your storyboard, your timeline, your plan, simply because you are the author and you are the director. Okay, you are the director of the video, so you need to make this kind of plans, so-called storyboard, to maximize your design presentation effect when you create your video presentation. But fortunately, I'm not going to ask you to submit this kind of video-based presentation. Again, I'm going to ask you only submit this part, okay? Animation part, something like this. That's the option 2 for your final project, okay? And next week's lab exercise, we're going to deal with this part, how to create animation clip by using 3D Max, okay? A quick review about what we have learned, what we have walked through this semester in terms of theory and behind the technology part quickly. Now it's time to move on for the lab exercises, okay?